Hey, what's up, Algebra 2? This is my first crack at a voiceover PowerPoint with a little video to support lesson 7.1. You can ignore this warm-up. Normally, you would pause the screen, do the warm-up if you wanted to, and then go over it. We didn't go over Chapter 6. We're going to start with Chapter 7 and keep up with the district material. So we will just skip through this. So before we spend a lot of time factoring polynomials, now... we're going to simplify rational expressions and complex fractions. So some new vocabulary for you. Let me see if I can move myself out of the way. Rational expression, ratio of two polynomials as an example there. I'm not going to read all that to you. If you want to read and copy down the definitions, feel free to pause the video so that you can go at any time more at your own pace. A complex fraction is basically when you have a fraction in a fraction. And what we do to simplify a complex fraction is we rewrite it as division. And you might want to remember as well, in order to divide a fraction, you multiply by the reciprocal of that fraction. And if you need help, feel free to look that up online anywhere. So here is our first example. We're going to talk about simplifying this rational expression. You can see it's already factored. Well, not factored completely because we could factor further the y squared minus 9, but what you can look for is any common factor. Since it's all multiplication with factoring, you can pull out the common factor of y plus 7 and eliminate those by dividing them to 1, giving you 3y over y squared minus 9. Under what conditions would make this undefined? And you need to think, what makes a fraction undefined? What is something that you are not allowed to do in math? And the answer to that is, you're not allowed to divide by 0. So you need to think what you're dividing by, y plus 7 and y squared minus 9. What number or numbers would make this, anything in this denominator, the bottom, equal 0? Think about what numbers you might think would make this undefined. So here's the denominator when it equals 0. If we factor out completely, we can factor out y squared minus 9 into y minus 3y plus 3 using difference of squares. Therefore, when we solve it, we can see that y equals -7, +3, and -3 all will give us values of 0 for the denominator. And that was what would make the expression undefined. So when they're asking, when is the expression undefined, basically just set it equal to 0, the denominator, the bottom, and factor and solve. These are problems for you to try on your own. So if you need to, pause the video and give this problem a try. Here is the solution. The x plus 5s simplify, cancel if you will, leaving you with x over x squared minus 16. Letter B, give this one a try. Under what conditions is this expression undefined? And the answers are -5, +4, and -4. +4 and -4 come from solving or factoring x squared minus 16 into x plus 4 times x minus 4. And that would be all three of the factors. Excuse my mouse writing. Just kind of playing around with that. Don't think I'll do that again. Okay, next example, we want to know for what values of p is this expression undefined. And we want to know when something is undefined, we need to figure out where it is that the denominator is equal to 0. So we want to determine the values of p that make the denominator equal 0. That's what's on the bottom. So we set the denominator equal to 0. We factor p squared minus 2p minus 15, negative 5 plus 3 times positive 3 is negative 15, negative 5 plus 3 is negative 2. Using the zero product property, we can see p equals 5 and p equals negative 3 will make this polynomial equal 0, which would make this expression undefined because we can't divide by 0. Okay, you try this one and see if you can figure out what values of p make this expression undefined. Pause the video if you need to, and then press play to see the answers. Final answers are negative 5 and negative 3. This polynomial on the bottom of the denominator factors into p plus 5 times p plus 3. So the solutions are p equals negative 5 and p equals negative 3, which make the denominator equal 0, which make the polynomial undefined. Okay, next an example, simplifying using negative 1. If we look at this, it's really hard to cancel anything out because we have addition and subtraction going on here. So we need to factor out. Only multiplication and division allow us to cancel out in fractions. So when we look at the top, we can see a common factor of a to the fourth, pulling out or leaving us with b minus 2. On the bottom, we can see we have a common factor of a to the third, leaving us with 2 minus b. Now, b minus 2 and 2 minus b are very similar, but they're not exactly the same thing. If you see what's going on here, what happens when you reverse the order of subtraction, you just get the opposite of the answer. If you factor out a negative 1, then you can turn it into 2 minus b, and which will cancel out the 2 minus b on the bottom. A to the fourth and a to the third leaves you with an a on the top. Therefore, this whole expression right here simplifies to negative a. Very complicated, so you might want to pause that and give that another look. Once you're ready, see if you can try this one. Special hint to factor out the x to the fourth on the top, factor out an x to the third on the bottom, and see if you can come up with an answer for this one. Pause it if you need to. And here is the solution. Very similar to the last problem. So, couple of key concepts here for you to review. Multiplying and dividing rational expressions. When you multiply fractions or rational expressions, you multiply straight across. When you divide, you change it into multiplication by the reciprocal, as you can see explained down here. So please take a look at this. Again, pause it if you need to. And let's multiply. Now, we can multiply and simplify, or we can simplify and multiply. I like to simplify before I multiply because sometimes reducing fractions can be hard. You can simplify anything on the top and the bottom, or on the top and the bottom this way, kind of like cross products. Like, for example, if you look at 8x would be 2 times 2 times 2. Sorry about that. And then 7y times y. And then 21 is 3 times 7 times y times y times y. And then 16 is 2 times 2 times 2 times 2 times x times x times x. I think they make it a little bit more complicated than necessary here. Once you cross out or reduce to 1 all of the products, then you're left with 1 over 6x squared y. Taking a look at a division, 10mk squared divided by 3c squared d divided by this fraction, 5m to the fifth over 6c squared d squared. First thing we do with division is we change it into multiplication, so we multiply by the reciprocal. You want to flip it over. Then, very similar to last time, break it down. 10 is 2 times 5 times m times k. 6 is 2 times 3. And you can see the breakdown of the factors, canceling everything out or reducing everything to 1. And simplifying gives us 4k squared d over m to the fourth. Give this one a try. See if you can reduce it in its simplest form. And the answer is y over 2x squared. Letter B, a little bit more complicated. It's division. See if you can rewrite it as multiplication and reduce it as well. Pause it if you need to. And the answer is ab squared x over 8. Polynomials in the numerator and the denominator. Addition and subtraction are your enemies when you are trying to multiply and divide or cancel things out, if you will. You can't cancel things out, even though that's not really a thing, over addition or subtraction. So what we need to do is we need to turn it into multiplication by factoring. I see the top here as 1 minus k squared. I'm thinking difference of squares. This I'm thinking I can factor. So what we do is we take this original and we take the 1 minus k squared and factor it into 1 minus k and 1 plus k. K squared minus 4k plus 3 factors into k minus 3 times k minus 1. Then, when we write it all as a single fraction, you can see that a lot of stuff cancels out. Of course, be careful, here's the negative 1, right? K minus 1 and 1 minus k aren't the same thing, but from those last examples, remember, they simplified to negative 1, as you can see on the side over here. Therefore, this whole mess just simplifies to negative 1. Letter B for dividing, same thing. Remember, when you divide, you have to rewrite as multiplication. Then factor everything. Remove the common factor of 2 from this. This is d plus 2 times d minus 1. This is d plus 2 times d plus 1. We write everything in a single fraction. We cancel out or divide to 1 our like factors, leaving us with 2 times d plus 1 over d minus 1. You might think that this stuff can simplify or cancel more, but it doesn't. Remember, addition and subtraction, you can't cancel things out over addition or subtraction, only multiplication or division. Go ahead and give this problem a try. Press pause if you need more time. The answer is 1, and give this problem another try. And press pause if you need more time. And the answer is 3 times d plus 4 over d plus 2. Complex fractions is just another way of writing division. It's a fraction divided by a fraction, so we write it as a fraction divided by a fraction. Excuse me. Which means we need to rewrite it as multiplication. Multiply by the reciprocal. And then you can factor everything and cancel out the common factors or reduce them by dividing by 1 and simplify with the final answer. Here is one for you to try. Pause if you need more time. When you rewrite as multiplication and factor, the final answer is 1 over a squared times a minus 3b. And that brings us to the conclusion of lesson 7.1. I know there was a lot in there. I had to go a little fast because I was running out of time on my free recording app. But feel free to pause, rewind, use your book, use Clever. Reach out to me if you have any questions in completing the assignment. Remember, we are completing the assignment that the district has posted. That is linked to the files page on our Microsoft Teams. There are examples in there, but I wanted to provide some additional examples for you as well. Take care.